Hi, and welcome to CFE Media's Virtual Training Week. For this session on condition-based monitoring with VFDs, Know the Future Today, we'll be joined by Jack Korzip, Business Development Manager with Motion Industries. I'm Gary Cohen, Senior Content Manager with CFE Media and Technology. And following our presentation, be sure to stay tuned for the live Q&A. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RCEP at rcep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RCEP. So let's talk a little bit about what you're going to learn today. This webinar will introduce a unique preventive maintenance tool that will enhance your ability to forecast your machine problems, eliminate downtime, and provide cost-effective planning solutions to maintain and improve your facility's production. We'll introduce and demonstrate the latest VFD, or Variable Frequency Drive software enhancement, which can now provide a single source, a reduce failure point tool. It can be used every day, everywhere in your plant to increase machine performance knowledge and productivity and reduce downtime. So here are some of the learning objectives we'll cover in today's presentation. How condition-based monitoring, or CBM, can be used for time planning and cost efficiency, advancing operational awareness with integrated communication platforms, demonstration of a single source low failure point monitoring device proven to be consistent and more accurate than time-consuming inspections by personnel, how to use the data to advance your real-time decision-making, and how CBM in a VFD is used for existing applications throughout a plant. For a seamless online experience, here are a few tips to help you out today. Additional resources can be viewed and downloaded on the left-hand side of the screen below the session's agenda. If you'd like to take notes within the session, just click on the left panel labeled Notes to do so. Please remember that this session will be made live on October 22nd at 12 p.m. Central, 1 p.m. Eastern. The question and answer session with industry experts starts approximately at 12:45 p.m. Central, 1:45 p.m. Eastern, or immediately after the presentation ends if it runs a little longer than 45 minutes. Answers will be archived with the session. You can see the Q&A details in the Meetings tab on the left-hand side of the screen. Zoom invite details can be found in the Additional Resources tab under Q&A session. And if you want to take the session again, that's not a problem. The session will be available on demand. Finally, if you're experiencing difficulties, please log out and log back into the session to continue. Attendees are eligible for 1 PDH credit for this event, airing on October 22nd, 2021, and it's categorized within the Technical, Health, and Safety, including Core Technical category for RCEP. This event is a live educational session presented on October 22nd, 2021, and on demand afterward. I'd now like to introduce you to today's speaker. I'll be your moderator, Gary Cohen, and today we will be joined by Jack Korzip of Motion Industries. Jack is a business development manager at Motion and has been with the company since 2001. With 35 years in the industry, his background includes positions as automation specialist and fluid power specialist, as well as in sales. Jack's formal education is in aviation as a technician, and he's certified by the International Fluid Power Society and numerous variable frequency drive manufacturers. Jack brings his deep industry experience with multiple product disciplines to offer unique solutions to the most demanding applications. Jack, welcome to today's Virtual Training Week session. I will now happily turn things over to you.
Thank you, Gary. Appreciate it. And hello, everybody. Let me share my screen with you and make sure we can all see this. As Gary said, I've been with Motion Industries as an electrical business development manager since 2001. I've been in the industry over 35 years. I've been involved in numerous projects from automation straight through design, engineering, and field service. So I've got a lot of background in a lot of different manufacturers for variable frequency drives and a lot of other components. But today I'm really excited to bring you this condition-based monitoring. This is a great way to increase efficiency using condition-based monitoring for your condition-based maintenance program. So we're going to do this with a unique twist. We're going to use a VFD for this product. It's an embedded product inside the VFD, and I'm going to take you through that in this presentation. And then we also have a little demo presentation to show you how it works at the end of the PowerPoint presentation. So let's get right into it here. Danfoss Intelligent Drives. The VLT condition-based monitoring is embedded inside the Danfoss Intelligent Drives. And those would be the automation drive series that you see below, the FC302, 202, 102, and the 103. The breakthrough technology is implemented on the levels of the stator winding integrity, the vibration envelope, and the load envelope. Those three are the monitoring points we will use. The overview, why is condition-based monitoring needed? The condition of a piece of equipment typically degrades over time. Condition-based maintenance is the easiest and most intuitive maintenance technique based on data of the actual application. So the data acquired is used to monitor the health of the equipment and service. The idea of condition-based monitoring is to detect the potential failure very early in the process before the actual failure occurs. This is very unique. There's a lot of ways to do this with a regular variable frequency drive, but not as accurate and not as early in the stage than with this software. It's a very unique software with the algorithms programmed into this software. The Danfoss condition-based monitoring system is really that effective tool that will improve your condition-based maintenance program. So what can you expect from this? Obviously, downtime reduction. As you reduce, as you know ahead of time, and you can grab those faults and problems as they occur, you can obviously save yourself some downtime. The elimination of unexpected production stops. Production stops are very expensive, besides time consuming. So if you can eliminate those by knowing in advance what you're expected to see, you can easily save a lot of time, a lot of cost, a lot of downtime with those production stops. And more importantly, I feel it's maintenance optimization. So if you can see the future of what's happening in the equipment as far as failure or things that are about to fail, you can do a much better job at planning your maintenance and your repairs and your purchases and your rotation on inventory and those types of factors. So there's a big cost associated with that for a lot of reasons. Reduction in spare parts inventory is a huge one. Keeping inventory is very difficult because you have ambient condition issues, you have space issues, you have obsolescence issues. And even today, what's even more difficult, becoming more difficult, is logistical issues. So if you can't grab that data ahead of time and properly plan, you're going to find that today it's very difficult to get a lot of parts. It's to get a lot of things from overseas or wherever that machine or the equipment comes from. So there's a lot of challenges on the logistics side because of the COVID and everything else that's happened. So those are really the big important issues there that you run into. The next thing we talk about is, condition-based monitoring. Simply put, what is it? Well, condition-based monitoring, it's a software function designed to monitor the change between actual and initial values. The CBM, it's not a fault analysis or diagnose system, and I'll talk about that in a second. It's based on thresholds and warnings. So you have a baseline of a clean running machine. If you look to the far right on the PowerPoint, you can see there's actually a chart there where you have a healthy condition in the green. You have a yellow condition where you're starting to experience some issues of degradation. And then you have an orange condition where those issues are getting a lot worse. Once you get to the red condition of a fault, now you trip everything, shut everything down. Now you have catastrophic failure. And that's the condition you don't want to get to. So this is a baseline type of measurement where we want to measure all the great things that are going on in a machine while it's running in prime condition. And then we want to set our thresholds to say, hey, when we get to this level, this is where we want to have notification so we can plan from there. So we get 2 warnings and 1 alarm. The 1 alarm will actually shut the machine down. So that's what you have to be careful of there. And you can use any piece and portion of this software. It's not that you have to use an all or nothing. So it's very unique in that. Then once you get that information, you decide how you want to use it. And that goes into your maintenance program. So that becomes your condition-based management system on how you deal with all that information coming back. How does it work? Well, each function is represented by an analog numeric value inside the software. So as you set up your baseline and you set up your alarms and warnings, that's all a numerical value that's inside the software. You're looking for the motor winding integrity, actually. You're looking for vibration, which is an external sensor feed. We'll talk more about that. And we're looking at the actual load envelope of how that motor is being loaded. And that's a view of how the machine is acting as well. The drive needs to run a baseline, like we said. So what we want to do is, once the machine is broken in, if it's brand new or if it's been running a while, we want to develop a baseline of the data and the values as the machine is running in a great state. So we develop that baseline to learn the values of the normal operation. Then during the operation, the actual value is compared to the baseline. So once we get into operation on the machine, we're actually comparing those values to the baseline that we just recorded. Then there's two warning levels, warning 1 and warning 2. And you have to define those through the thresholds. What warning levels are relevant to that particular machine? So a little bit of machine knowledge is really critical. And we'll talk about some other things, but there's a little bit of setup that goes involved with this. And of course, the indicators you see, if you do a remote access type thing, or if you're looking actually at the software while you're measuring or you're monitoring the values, you'll see the VDMA colors of green, yellow, orange, which is warning 2, and then red, which is fault. So it's kind of a universal color pattern, which is really nice. So baseline and thresholds, this is the brains really, and the meat of the heart and soul, I guess, of the software. During commissioning, the drive determines the normal level of monitored values. So as you commission the drive and you start it up and you plug in everything you need to get it running on the application, once the application is running, those regular normal values will be determined at that point. You've got a well-running machine, and that's where you want to measure those baselines and have that data so you can monitor against it. The speed range at that point is divided into 20 points. So how this actually works is, on a typical machine, we may run through a speed range. Let's say 500 to 1,000 RPM is the speed range in the process that we're actually running through. So we take that 500 to 1,000 RPM and we divide that into 20 data points. And we store those data points for that information on how the machine is acting, both motor stator-wise, with the integrity of the actual winding inside the motor, the load envelope on how the machine is handling, and the vibration envelope, how that machine is vibrating through the speed ranges. Because as speed changes, you also get different frequencies of vibration. So you have to have a good monitor of that. You have a couple baseline options. You actually have a manual type of run baseline, and you'll see this when I do the demo on it. And it'll make a lot more sense when you actually see it. But you have a manual run. Now, I made the example of 500 to 1,000 RPM. If we do a manual run, we actually do a sweep from 500 to 1,000 RPM at a predefined period of time. But we do it all at once. So sometimes that's not hard to do if you have a fan or a pump. But sometimes it's very difficult to do if you actually have a conveyor or a more complicated machine. Can't always run through that speed range without creating problems. So the second choice is what we call an online type of baseline run. And what that is, that's actually the software sitting in the background, gathering all the points over a period of time. Now that period of time can be 2 hours all the way up to 6 months. So you have a lot of versatility with this. And it's like artificial intelligence. It sits in the background and keeps gathering the data as you go up and down through that process in the speed range and develops a baseline from that. So very unique. So you can cover both sides of that spectrum, which is really great for the software. Once you develop that baseline, you have thresholds. And these thresholds are what you determine. Now, that could be from the vibration standard. I believe it's 20846 or 20816, the ISO standard, or your own measured type of baseline, if you've done any external measuring for like vibration or load. Motor thresholds in the US, it's very difficult to get a lot of that type of information. So I'm going to give a plug into the download manual. Now, manuals these days never come with drives or anything anymore, as we know, phones, drives, or whatever. So you have to download the manual, and you want to do that because in the manual, it not only explains the parameters that you're looking at, but it also has formatted defaults. And these defaults have been defined over a period of beta testing for the last 2 to 3 years out in the field. So we have this software running in Europe. We have it running in the US and some major food and beverage industry. And we're doing remote monitoring. And we're also defining how the different applications affect the software and the easiest solution for you to begin to program that and put your own defaults in. So the defaults are a great place to start, but you do have to download a manual, and you would have to anyways for this type of software because it's an advanced software. But you have 3 threshold limits that you want to set. The choices are absolute. If you really know your machine and you know your levels, you can certainly set your absolutes in. A lot of people will do vibration testing as a regular basis on a motor. You get a new bearing, number of bearings, et cetera. You do vibration testing. So you might know your absolutes there, but I doubt you're going to know your absolutes when it comes to motor winding theory or any of that information inside an electric motor. Load, you may know your load envelope absolutes, but you have a choice of absolutes, offset, or factors based off the baseline. How do you set up and perform this? So the monitoring is performed continuously, comparing those thresholds to the baseline. During a normal operation, the actual values are compared to the threshold. When those monitored values or parameters exceed the threshold by a predefined time, which you do set in the software, you'll get a warning or an alarm. The warning you'll get 2, of course, and the alarm will trip the drive. So you have to be careful if you're in a production run and you're setting those alarms. You have to be pretty confident in what you're doing to set the alarm in that case, but it's a very useful tool. And I definitely want to mention the timers involved in this because you have 2 warning timers and you actually have a alarm timer. And what that does is with all applications, you get these short transients of issues that go on. You get spikes in load. You might get, if you get a load spike, it's going to affect the winding of the motor, which is going to affect that feedback and that value. So you do have timing things that you can set up to 60,000 seconds. So you can go from, I believe, 1 second to 60,000 seconds. You'll see it on the software when I actually show that. So you don't get any any type of faults triggering or transients. When we take a look at the screen here and we're looking at what we're doing, we're really taking the voltage and the current spectrum and we're putting it through the drive. That's how we're kind of measuring that winding integrity. Then we also look at a load envelope. And what's important with this is when you look at the green or bluish line, a little colorblind here, but the line with X is in it in the center to make it easy. You have a high limit and a low limit. And both limits are very important. You need to know if you have an overload, but you also need to know if you break a belt, a coupling, or you have a leak in a water system or an air handler issue. So you have the choices of high and low limits. Then we get into a vibration type measurement where we compare it on a scale as we run through the speed range. And this is really a very unique software. This isn't simple measurements. These are very high defined algorithms in there, patented algorithms that are very performance driven. So it's very unique. Let's talk about the 3 different types of monitoring values we have. The first one we'll cover is motor winding monitoring, which really what we're doing is we're really monitoring the actual integrity of the winding. If you look down in the far right corner, you should see a picture of a winding with a little bit of a burn spot there. That's around the turn of that winding internally. So when you look at the inside of an electric motor, you have a bunch of wires, and they're special coated magnetic wires that go in there, mag wire, and they have insulation on them. They'll have VFD insulation, they'll have regular insulation besides. But as that motor gets power, that winding likes to move. And you do dip and bake it with a process. We're not going to get into motor theory here, but with that process, you still have movement. And as load and spikes come through that, you have a lot of abrasions, and you do get overloads and that type of thing. And drives, VFDs, are notorious for sending out high voltage spikes at very high frequencies. So you you get a lot of problems and breakdown in the first 3 turns of a coil going into a motor. You'll see a picture of that. That's called, what you're looking at there is a turn-to-turn short developing. And that develops over time. Now that can happen. And as it starts to degrade, you can actually still run that motor. You'll have signs, but that motor will still run until the point of total failure. So this software helps analyze that motor current signature and detect that motor winding damage, at a very early stage. And you have 2 points of testing. You have warning 1, which says, hey, we're starting to degrade, and warning 2, which says it's getting pretty bad. Let's do something before 3 comes on, which is the alarm, and shuts everything down, and we have a complete burnout of the motor. So not only is that expensive in production and time lost, but then you have all the maintenance associated with all that, with the motor failure. And that could cause other things to fail, obviously, up the line. So it becomes a major issue. The monitoring function triggers the early warning, for the stator if you have that insulation fault. A good point to start mentioning here is there are 2 values that do not need external sensors. One of them is the motor winding. The drives today are extremely sophisticated. They have a ton of sensors in them. They have extremely high processors. I've been in this many years. I've been in this in the 80s when drives came out, and they basically blew up. They didn't have a lot of sensors or capabilities. If you had a ground fault, you literally physically blew the drive up. Today, that's not the case. If you have a ground fault, the drive just trips out. If you have a lot of faults, incoming, outgoing, the drive trips out. It saves itself and from catastrophic damage. So you do not need any type of external sensor. You use the internal monitors, the internal sensors, and the internal algorithms in the processors to develop this technology. That's very unique. Once a drive sends the warning or the alarm, it can send it various ways. It can show it on a keypad. It can show it on a communication bus network. If you have Ethernet, Profinet, any bus network you have, pretty much cover them all these days. Everybody does. You can send it that way. You can even tie it to a relay. Actually, it's not on a PowerPoint, but you can certainly tie a warning or an alarm to a relay in a drive, or 2 relays, and or multiple relays, and give yourself hard IO warnings. So you can time the lights. You can do all different types of things. So there's a lot of information, a lot of avenues and communication paths, which is really handy to have. The second monitoring value that I want to talk about, remember there were 3, is vibration. One thing you'll notice right off from the picture is on the right-hand side of the motor feet, there's a vibration sensor mounted. Now, this is the only monitoring value that we need an external sensor for. And any sensor will work. And as long as you have an analog sensor coming back, either 4 to 20 milliamp or 0 to 10 volt, most common is 4 to 20 milliamp, a current source coming back. And they're usually velocity or acceleration type sensors. So picking a sensor out can be a little bit of a challenge because the sensor should be sized in the range of what your typical machine vibration is. So that, there's a lot of help here with people from Motion and people from Dan Foss in the engineering department. We can help you make these decisions and help you apply things properly and get the setup properly. So the overall vibration measurement, there's no frequency domain for really that measurement. And I'll explain that. Vibration happens at all different levels. Drives have skip frequencies in them because there are resonances, and those vibrations, heavy vibration, can happen. Extreme heavy vibration that can actually destroy the actual fixture. That, let's say a fan, for instance, that's not exactly weighted or has a weird vibration at a certain speed range. So it happens at different spots. The function of this is really on vibration to check for any type of unbalances, looseness, misalignment, any type of mechanical resonance you're going to run into. And you have capabilities with the drive to work around those resonances. You can't really identify early bearing issues, early bearing wear out issues. Unfortunately, when you get the vibration, you've already created some problems inside the bearings somewhere on the machine, be it the motor, be it the machine, or wherever. It could be mechanical things loosening up, et cetera. But you can't really identify early stage bearing failure, unfortunately. That still requires a maintenance program on that type of measurement. But what you can do is you can get the indicators back. So if you have a quarterly type of maintenance program, preventive maintenance program, and you're going around with a vibration analyzing meter and you're doing baselines on everything and you're doing comparisons, which is typically what we do now until this software type stuff came out, you will have an indication, a good indication where specific problems occurring, and you can pay more attention to that before you have some serious issues. Drives correlate the vibration with motor speed. We just kind of covered that. There are speed ranges where resonance happens. It's the nature of balance, and it's the nature of the way machines are put together mechanically. It happens, especially HVAC. One point I love to bring out about this type of software, this embedded software in a drive, it's permanent monitoring. It's 24/7 versus occasional service checks. Like I said a couple seconds ago, if you have a PM program where you're running around once a quarter and you're doing vibration measurements with a tool, that's at that moment in time. So 10 minutes from that time, you don't know what's happening. With this software, you know what's happening 24/7. As that machine is running from when it starts to when it ends, you're monitoring that 24/7. That's like having somebody with a tool just sitting there monitoring your equipment at that time. So it's very unique. Lastly, let's talk about the load envelope. The load envelope, the function of it, it learns the load curve of the application, and it detects wherever that load moves above or below the baseline level. So as we're looking at a machine and we're looking at the load values, it's very important because as things start to wear and degrade, our load increases. And we want to know this. We want to know it ahead of time so we can catch problems before they become catastrophic and extreme downtime and extreme cost from that. So it's really useful in that fault detection, especially even with passive loads. You want to know a lot of times if you're having bearing failures, if you've got broken belts or couplings, if you have broken impellers and water pumps and that type of thing, or you're following them or you're wearing them out, because the actual blades will wear out in there. Or if you have clogged filters, and leakages in piping and that type of thing in systems. So having that information on the load, anything that's load related, this will give you an envelope of high limit and a low limit. Very important for both limits. You want to know if you're overloaded. You want to know if you're underloaded, because there's problems in both conditions. When we talk about user interfaces, again, this is an embedded drive software. It's there to protect your application. And, we have different ways to display this information. We have the keypad, of course, on the drive, which you'll see in the demo. We have field bus. So if you want to communicate it over your Ethernet bus or Profinet, Profibus, Modbus, whatever you use in your plant. And even on the HVAC side, if you're doing BACnet, LonWorks, any type of communication building management system. So in the HVAC side, really pretty unique because you can take all this information and go over that type of building management system, as well as the industrial side where you're looking at the Ethernets and the Profinets, Profibuses, and things like that. And last but not least, the Danfoss VFD programming software, the MCT10. That is 2 versions. One's a free version, which covers 99% applications. But since this is an advanced software, there's an extremely low-cost software, the MCT10 Advanced. And that's what we use to program it. That's what we use to monitor it. So with that software, it's hot swappable. We can walk and actually do a drive that's running on a production line, and we can plug in with a USB cable. And we can bring up a lot of different values, which are very beneficial to the maintenance personnel and technicians. But we can also bring up the condition-based monitoring. So if we're seeing a warning or we're getting information back to say we're having warning 1, warning 2, we can actually plug into the drive and we can take a look at those warnings and see where we are in a level. So it's a great software to use, and it's extremely simple to use. What are the key values? Permanent monitoring versus selective regular checks. Again, this is a big thing because you're getting real live data 24/7 versus a spot check once, whenever your PM program is, quarterly, weekly, monthly, that type of thing. You're transitioning from a scheduled maintenance program to a condition based maintenance program. Now we're talking about, it's play on words here, we're talking about condition-based monitoring, but we actually use this software in a condition-based maintenance program, which means we're looking at things in a different way than just Scheduling maintenance. Why go change that bearing 2 weeks from now just because it's on the list when there's nothing wrong with it? It adds inventory, it adds cost, it takes time away from technicians, and really it's a waste of money actually. So it's cost involved in that all the way through the whole program. So this takes you to a different level of maintenance planning. It's a cost-effective solution versus external third party. Sure, there are other people that have sensors and everything you can put on equipment, but you have to tie all those together, which means you have a learning curve to program all those. You have to make sure your wiring and everything's proper. Where you place those could be critical. There's so much involved in combining multiple products. As an ex-panel builder that I am, a UL panel builder in a UL shop, I can tell you with great honesty here, where you place things is extremely important, especially in a panel or on a machine. If you place something next to a welder, you're going to have all sorts of issues. Any type of high voltage next to low voltage, or this type of communication levels of voltages, major issue. You can blow components up. So that's a big thing. Increase application uptime. If you know in advance, you're obviously going to be able to do that. Hard to get to remote locations. I mean, you could have a pump 20 foot in the air. You could have a motor 30 foot, 100 foot in the air. Some of these game parks have them 100 foot in the air, 200 foot in the air. You have to climb a ladder to go look at data on these drives if you have a problem. Wouldn't it be nice to be able to sit at your desk here, take a look at your condition-based monitoring, and see where you're at, see where your failure points are, and then schedule your maintenance. I've seen people take motors off 200-foot towers with cranes. Cranes are expensive per week. We all know, the expense of doing maintenance. So just having that ability to do remote monitoring because of distances or buried inside a machine, et cetera, is really very unique. This is important. This software is fantastic, but if you don't apply it, it's worthless. You have to integrate this into your monitoring system to create any value. You have to create a condition maintenance plan. Otherwise, it's great software, but it's like anything else. You've got Excel, you got Access, you got PowerPoint. If you don't know how to use it, or you don't use the features of it, it really doesn't do you any good. So it's a very unique system to have. There's a lot of outputs. You can have relays, digital outputs. You can have serial communication, of course. You can have remote monitoring over, the Internet 4.0, so IoT stuff. This is all for the future as well. So it's geared to go down that road. So it's a great product to have for communication. What kind of benefits do you really see with this? Or, what have people studied? So over in Europe, they got together with the European Commission, Danfoss did, and they looked at eco design and energy labeling, and they looked at what kind of reduction can we see? The traditional PM scheme where you say, hey, every quarter we're going to go lubricate the bearings in this motor, or we're going to go do vibration analysis. We're looking at, almost up to 30% maintenance cost reductions. We're looking at up to 45% downtime. That's huge. That extrapolates out to a lot of cost in dollars. When you look at breakdowns, when do they happen? They happen in emergencies when they happen. They're not planned. And 70-75% reduction in breakdowns, because ahead of time you know what's going on, and you have early warning. You just don't have, hey, my amperage is going up, I'm seeing it on the drive. You have different levels that you determine are warning levels that you can react and have time to react to. Order equipment, wait those 10 weeks for that stuff to come in, et cetera, with the logistics. And then when you're looking at production improvements, I mean, you can have up to 25% or more for production improvements because it's affected by everything else down the line. So it really helps you reach those potentials. Great software for that. How do we get this software? So we order a drive. Now, we have drives in the plant. They're all over in our every plant. Where do we get this? Well, we can order it brand new. The little slide on the left, number one, we actually put it into the software when we develop the part number for it, and we order it pre-programmed from the factory. Quick comment on this. Every single drive that is produced now has all this special software buried in it. So we just have to open it up. Now, to open it up, you either need to get it from the factory opened with a license, or you need to buy a license. So you could have a drive you bought 2 years ago and you said, boy, this is great. I want to try this on my drive. Well, you can. You can buy a license. You put the license in, and I'll actually show that on my demo where that goes in Group 50. You put the license in, it opens it up, and it shows up in Group 50, and you know you have it. So it's unique in the fact that you can get it from the factory, but if you already bought your drive, you can get a license as well. We're taking a quick glimpse into the future because nobody has this. Nobody has the embedded capabilities, software, and algorithms except for this drive, this Danfoss drive. We take a look at this. It's a unique tool to forecast your machine problems. It's cost effective for planning. You know, the advanced operational awareness is really the key to this. Knowing in advance of what's happening, knowing what's happening in the future helps you today make decisions, right? And it's very important. It's a single source, so you have a low failure point. Everything communicates into the drive. It's a hub. It's a sensor hub. It's a communication device. It's an analyzing tool. It's all buried in the processor of these drives. So it's one point versus having maybe 5 or 6 different points plus cabling issues, connector issues, condensation, everything else in the atmosphere that affects all that type of thing, the radiation, the EMI, RFI, everything involved that we deal with every day in plants with everything, let alone drives, PLCs, HMIs, et cetera. So it's accurate, it's consistent. Why? Because we are sending data straight into the drive processor and we're getting information from that processor. We're not going through handshake modules of external components with scan rate times and delays and all those things that's involved in that. So it's really accurate and consistent. It's real-time data. And it's embedded. Again, being embedded, everything above it falls into play. It's a one package solution. You just hook up to it. It's easy to configure and use. One of the things that I really enjoy bringing out to customers in the field is simple products that are effective. And there's a lot of applications. I've seen most all applications through the years, through 35 years of doing this. And the most complex things we deal with is programming drives, programming HMIs, et cetera. So it's very easy to configure and use, and demo will show that. So we want to unlock the power of this CBM, this condition monitoring. Today's drives, their processors are packed. I mean, they're fast. They have a lot of room in them. Why not use that? Why not allow them to be sensors? Why not allow them to collect that information and give us information? We should. Drives are a keystone. They're on every application. They're on every automation application. They're on fans. They're on pumps. Anytime you need a production, something to run in production to tailor that production for efficiency, you've got a drive on it of some nature, be it servo type thing or a pulse width modulated variable frequency drive or whatever. You've got a drive controlling the speed and torque of that motor. Let's use that drive. It's already out there. Why not? It can improve maintenance, reduce your cost, and get you set up for Industry 4.0 for the future. The CBM, it enables maintenance departments to become more predictive in their process. If you're more predictive in your process, you're going to save more money, have less downtime, less emergencies, less stress, and less problems. Let's face it, when things blow up and they happen, and we don't know they're going to happen, it's always at the worst time. It's 2 o'clock in the morning on a production run, and now we can't get a part, or we're down, the machine's down for 6, 7, 8 hours or longer if we have to order something in. Wouldn't it be great to know ahead of time that this is coming? And you can actually do something about it. You can plan for that. Planners in plants, that's their job. They plan for those shutdowns. They don't plan for emergencies. They plan for shutdowns. So we can make this a plan for shutdown instead of a react to emergency. That's excellent. And that's really what we try to do. That's the presentation on this part. There is a demo to follow. And Gary, I really appreciate the time to show this. I think it's a really unique product. It's the only thing out there like this at this point. Everybody, I think, is trying to catch up to it. But the special software and the features and the algorithms written, they've been tried and tested over the last, I'm going to say, 3 years in the field that I've been working with it. And we're going to do a demo after this. So I appreciate you staying tuned in for this. Okay, we're going to take you now into the programming side and show you what condition-based monitoring looks like on the programming, as well as running a real drive and showing it what it looks like and how it's displayed on your options there. So I've connected to a drive, one of my demo drives here, and I just connected into USB. It's the simplest way. This is a standard MCT10 drive setup software.
Now this is the advanced version, so there is a cost for this. It's a licensed software, but it's basically the same as the basic one, just with enhanced features. So we can program and monitor the extra advanced software inside the drives. Now CBM is a software that's embedded in the drive, and we just have to turn it on either when we purchase it new or with a license if we have an existing drive. Now we can do that. We can go in, buy a license. If we have a drive capable, we can plug that in and the CBM will show up under the licensing. So you will see 45, 46, and 47 groups of programming available when it's enabled on the drive. You will see these parameters. Now when you plug into the drive, as I have here, and it shows up on my USB port, I have a little tab down here called condition-based monitoring, and this is a plug-in feature. This will only show up when you plug into the drive. So at this point, I am plugged into the drive and I've enabled my condition-based monitoring plug-in feature. This is the easy button. All of these parameters that you see here are grouped and organized under the CBM plugin, and it makes it a very easy and efficient way to program this feature. So let's go right to this home page and I'll show you what I mean. We have two baseline runs, a manual baseline run and an online baseline run. And then we have the threshold folder and of course a monitoring folder when we want to monitor as we're running. So let's take a look at the threshold folder first. In the threshold folder, we have a bunch of envelopes. And in these envelopes is where you set your limits for all your either stator, which is the winding integrity, the load envelope, or the sensors, which can be vibration sensors. Now these sensors, there's 4 of them currently that the drive can handle. And the sensors are an external device. Of course, the stator and the load takes its values from all the tools that are already inside the drive, such as the processors and CTs. But the sensors are an external device, such as a vibration sensor, and that has to be communicated to the drive. So we do that via the analog output of the sensor, and we stick that in the analog input of the drive. And I'll show you that when we program those. So at this point, we look at the page. We have a lot of information on this page. We have color coding for ISO. That sets up our warning levels. It tells us where we are. We have little signs here to tell us what we're in here for a statistic and how we're using that versus the baseline. So you can see that embedded in here. Depending on how this is set up and using the manual, of course, this may look a lot different, probably will look a lot different because I just wanted to set this up this way so you could see it. But we can set the interpolation either linear or either step, easy enough. We have choices for average, which is mean, or standard deviations if you're not a statistician. We have choices for how to set the alarms and the warnings with absolute or offsets, etc. And then we would plug in these numbers, easy enough to set. We would plug in a number. Let me just change this so you can see where it's coming up, and we can easily set that in there. We also have warnings in here, the time delays. So these are warning time delays and alarm time delays. If we set these up when we fall into a warning or we fall into an actual alarm, this will give us a delay before we get a communication of that warning or alarm. So that helps with nuisance trips or any of that, bad information we might get depending on, how the process is running. So as we go down, we have a way to calculate, once we do all these settings in the different folders, we have a way to calculate and generate all those against the actual baseline. Now, remember, it affects all functions when you push this button. So what we want to make sure we do is set up all these folders first, whichever ones we're using. And then we will generate that. Now on the very bottom, we can go back to the home page at any time, or we can go straight to the monitoring page at any time. And once we're in the monitoring, that means it's live and it's monitoring the drives, it's running. Okay, so let's go back to home. And at this point, we're going to set up a baseline. So again, we have the manual baseline, the online baseline. What's the difference? Let's look at online. Both baselines, you have to tell it your RPM range of your application. That's where you set it up. You can either plug it in yourself there with the keyboard, or you can use a slider to do it. Doesn't much matter. So I'm just going to plug it in 1700. We're going to do a new one. We're going to enter the range, and then we're going to pitch next. But when we hit next, like I said with this plugin, Everything is logical. It takes you to the next step. So it makes programming very easy. It wants to know, it's telling you to enter the information in a logical order. So that's what we're doing. Now, online baseline. What that means is we're developing the baseline, all the criteria of that run from 100 to 1700 RPM. We're dividing that into 20 points of information. We're developing that and storing it in the baseline data parameters. And we are doing that over a period of time. So let's say we've got a machine. Let's say it's a conveyor, and we've got a whole bunch of boxes on it or something, and we just can't run that from basically 0 to 1700 RPM in a minute or 2 or 30 minutes. Not to get a true indication of the load. We need to let it run while the application's running. This is what this is for. So while the application is running, this software sits in the background, and it allows you to pick how much time period you want to take before you gather all that information, all that baseline data. So from there, you would hit next and move on. But we're going to do a manual baseline because this is a demo and we only have so much time. So I'm looking at setting up a baseline. At this point, I'm just going to pop the values in. We are going to measure between 100 and 1700 RPM on the motor. We're going to pick 20 points out of there. It's already chosen for us. The machine, the software is going to gather all this data and it's going to store it into our baseline data. We are going to do that manually in a minute. So what this means is if I choose 1 minute, that means when I hit the go button to gather this information, it's going to run from 0 to 1700 RPM in 1 minute and gather all this data. All these points of data are going to be registered in 1 minute. Now I could choose 30 minutes, an hour, 2 hours, whatever. So if you had the ability to do that, let's say it's a fan, you could do it. It might be an easy way and a quick way for you to set this up. So once you're in there, you hit next. Again, logical order, it wants the next step. Then it says, hey, remember, the 4 sensors are the only thing that you have external that you need to plug into the drive. So they are analog inputs to the drive. So we're going to choose the analog input. Now the standard drive has 2, 53 and 54. All the automation drives do. I happen to have a card in here with 3 extra analog inputs. So I can accommodate all 4 sensors plus a speed pod into this drive if I wanted to. Well, for test and display purposes, I'm just going to use 1 analog. And I'm going to use a voltage input on my end. But normally this would be set up for the sensor. So if you had a typical vibration sensor, they're usually 4 to 20 milliamp. They're usually so many millimeters per second. That's where you enter the unit information. But I'm not using that. I'm just using something to fake out the drive to show for a display. So this is how I've got it set up. Once you set this all up, you go ahead and push next. Now it's going to ask you, let's create the baseline. Finally, this is the heartbeat. We're creating the baseline of a running machine in production that we're going to monitor 24/7. Okay, I'm going to bring something in here, a little keypad. This is right off my demo here. And this keypad, I lost my mouse there, is actually live on my demo running because we're live on a real drive. So I'm going to create this. Now, right now, we're running, okay? So I'm going to show this just for fun. I'm going to try and create a baseline. Let me do that again. Create a baseline, and it's going to say, hey, drive's not ready. You can't create a baseline. Yeah, if you see down here, I'm in hand mode and I'm running. So let me turn that off. See my thumb come in there, turn that off. Now, I can retry it. Or I could have just done it from the beginning and turn it off. But I wanted to show you that if there is an issue, it won't let you go any further. So at this point, it says push the hand on. The keypad says push the hand on. So I'm going to go ahead and push that hand on button, and I'm going to initiate that baseline start. Now we're initiated a baseline start. Now you can see it starting here. It's gathering data from 100 to 1700 RPM. It's pulling in the vibration, the motor winding data, and also the load data. And you can see on the keypad also that it's running the baseline run. Now you can see it's running, it's in hand mode. We're gathering all that data. We're time stamping it. We're date stamping it when we start and stop. And we know the duration, how long it's going to take to gather this data. So at this point, you know, we're really looking at the LCP 102, the graphic keypad that comes standard with every drive. It's not an extra option. And this thing will data log. It will graph like a scope. It has easy to push buttons for alarm, HOAs, it has indicating lights on the side, even has a condensed programming manual in the info button over in the far right in the mid center here. And the OK button does the selection and storing. Very simple keypad. By the way, this is an IP65 keypad as standard. So even if you mount this on the door of an enclosure, you have the IP65 integrity. So it's really unique. So we've created the baseline, and you see the green baseline created, and we're at 100% ISO colors here. And even the keypad says, hey, we're successful. Press the OK button in the center to let us know. So good, we've acknowledged everything. So now we're back, we're in the off position. The motor has stopped running. So we ran from 100 to 1700 RPM on the motor. We've gathered all the data for vibration, motor, stator, and load, and we're ready to move forward. So let's move forward. We hit the next button. Now what does the software want us to program? It wants us to program the thresholds. Now I'm going to go ahead and just take this keypad out of here so it doesn't visually interrupt what we're doing. So now we've got to set our limits, which are our thresholds, and we're setting them based on the actual baseline. Again, like we spoke earlier, we have all the envelopes, and all these envelopes have to be set up before we generate the actual values against the baseline. But again, we set all these values up to the manual and the standards they put in the manuals. Now, one word about this. Danfoss does not charge extra for technical help over the phone. So for technical support, you can rely on them 24/7. And if you need field service, obviously we can do a cost, a chargeable cost on-site service from a factory certified rep to do that, service provider. So that is available, especially on the first go around with using this type of software. Now, we have set the thresholds, and over on the left here, those thresholds in group 46 have been loaded. The baseline has been loaded in 47, and we're about to go into the monitoring phase. But before we do anything, and to make sure those are all set and all the envelopes are filled up and programmed properly, we would want to go down and generate all those values into the actual baseline program so we can have everything there comparing against the baseline. So now that we've done that, all these groups over here are filled up with the right data. I'm going to stay on the sensor, and I'm going to also bring that keypad back in. So we want to run this. We're going to go into the monitoring mode. Now we can just choose monitoring here, or we can go at home. Now I'm going to push home because I want to make a point about something. Let's say we've already done this and we've been running this and monitoring the drive for a long period of time. We can easily just plug into the drive at any point in time while it's running. It's hot swappable, so you're not going to trip the drive. You'll automatically bring it up under the USB. This is live, so you're always running live. We're not into a project. This is actually running live, and we can just click on the monitoring. Now, the software here gives you a lot of data on the drive and what's going on with the motor, etc. But the condition-based monitor is much further advanced. This is a very early warning detection system, very developed algorithm system that gives you a lot of benefits in use. So once we're into the monitoring system, we want to make sure of one thing. All these folders that we are using are turned on to what we want to see. You'll notice in the sensors here, the last three I'm not using, so we're not monitoring those functions. But the other ones we are monitoring, and we are monitoring and warning. Now, they may be off like the other ones, or they may be alarm and warning. One thing to note about alarm and warning, if you are an alarm and warning and you do end up over this warning area here, you will trip the drive. So that's a problem. So it could be a problem, or you may want that. But keep note in mind, if you trip that drive and you're in production, you don't mean to trip the drive, that might create a real issue for you. So right now I'm going to run the drive. And as we run this drive, we see it come up in speed. We're green, we're good, we're well below. Everything's good, no warnings on the keypad. We're at speed. Now we're in manual mode on the keypad, so you see the manual mode down at the bottom here with the triangle at 1000 RPM. Now, as we have an issue and the machine degrades and we get over the first level, keep an eye on that keypad, now we get a fault. We're in the warning 1, we're over the yellow. Sensor 1, which is our vibration sensor, says, hey, we have a WS12, we have our first warning. That means we're starting to degrade. Now it gives us time. This is really early in the process here. It gives us time now to react to that, order parts, figure what our maintenance plan is going to be on that. And over time, as this degrades, watch the sensor on the keypad, you'll go into S2 warning, which means you're in your second warning now. So now things are getting worse. Now we need to really do something, because if we don't do something, we're going to eventually end up here. And we end up over an alarm status. If we have the alarm chosen in monitoring function, we're going to trip the drive, shut everything down. But if we don't, we're just going to know we're there. So even if we plug in, we're going to be able to see it, but we're not going to trip the drive. So that's great. You'll also notice down here in the keypad, besides the LCD display up here, the little warning light comes on as well whenever you hit these warning levels. So you can tie that to a relay. You can tie the alarm to a relay over the communication bus network. So it can be Ethernet, Profinet, Profibus, whatever. So this gives you a lot of flexibility. I'm just going to go ahead and set that back down, and everything will go away, and we're back in normal running conditions. So that is a great overview of what we're looking at with the keypad, with the drive running, and with the software MCT10 running on the drive, and the way you can use this as a tool, not only to easily program the drive with this plugin, but use it as a maintenance tool, even the Group 15, 16, and the condition-based monitoring all together as one whole maintenance tool for the machine itself. So great software, and we'll take questions after the demo. Thank you.
And again, thanks so much, Jack. That was all fantastic information. But viewers, please don't leave us just yet. It's time for the question and answer portion of the session, which will be starting momentarily. So this question and answer session will become part of the archive presentation. To participate live, just click the Join Now button in the next section. These details can also be found in the Additional Resources tab on the left-hand side of the screen. Please submit your questions using the Zoom question and answer interface, and we'll start that momentarily. Thanks.